All right, guys. So, welcome back. And in this episode, we are going to be going over the cruise control. So, remember, if we go back to how the cruise control was designed and what potential issues we may face, you'll remember that on the original steering wheel, there was a toggle switch which allowed you to turn your cruise control on and off, right? So we have this, that you press it and now cruise control stays on, and that allows us to have continuity in our resistance ladder, and as soon as we press that, it breaks it. Now, the other thing to think about is none of these buttons should function whatsoever unless this button is engaged. So we need to find a way to manage a physical connection while maintaining the fact that in our new steering wheel there is no physical button for that, right? So this is a heated steering wheel switch, but even with the non-heated one, you still don't have that. Really, this engage button just moves up here, and you have a cancel button, but they're still momentary switches. So what we're going to do is we are going to use our ESP32 to do a couple things. We're basically going to say, okay, I have 4 buttons up here, right? And let's pretend for a second we have a cancel button, because I want to design this so it can support both switches. We have our set minus, our on and off button, and our resist and our resume, and a theoretical cancel button. Now, the thing that we have, unfortunately, I would say going against us is that we don't have that toggle switch. So we're going to use the ESP32 to basically create a variable that's going to flip every time we press this on and off. And then only when this variable is set to true will these other buttons function. So that's what we're going to go ahead and work on. Now, admittedly, I will tell you guys, I have some of this designed out already. That's because I am not overly familiar with the ESP32. I have some level of experience with it, but I figured for the sake of our conversation here and for the sake of keeping things smooth, I kind of put this together ahead of time, but I'll walk you through the logic and the thought process. So the first thing we have to do is we have to use one of the I/O pins on the ESP32 to watch whether or not, well, okay, I'm sorry, there's a couple things. First, unlike the Melexis chip where we have a digital signal where we kind of just watch the digital signal via the LIN bus, we don't have that. What we actually simply have is a cruise control feed and a cruise control return. So we're going to have to use those feed and return wires in order to watch or watch and or what's the right word, observe the actual cruise control setup. So there's a couple different pins, there's a couple different things we're going to do. So let's first get it wired up so that we know what pins we need to watch and how we're going to feed it back to the ESP32. So the first pin we need to get is pin number 3, which in our actual, let me see if I can zoom out here with you guys. Okay. And what we have here is basically, let's plug into pin number 3. So again, I'm very familiar with this wiring diagram at this point. So we have pin number 3. Okay, so pin number 3 is in. And we'll just leave this alligator clip to the side. And then our other one here, and let's see if I have... Okay, now this will be our white will be our return. Okay, and our return is actually yellow is our return. Our feed is number 5. 1, 2, 3, 4, 5. Okay, so now we have our feed and our return in there, and we have our alligator clips here. Now, just to make sure we have them in the right spot, what I'm going to do is I'm going to get my multimeter, which evidently has been on for 3 days because I haven't looked at it in a couple days, and we're going to check our resistance to see if we have a resting resistance. And here we go. We have 8.82, and if I press on, you see that drops to 1.94. We have up and we have down. All right, so I know I've got the right pins. That's pretty much what I'm checking for. So rest easy, my friend. We won't need you for a while. Okay, so now we have to figure out how do we actually wire this up. So how we're going to do this is we are going to take the ESP32. We're going to send a voltage through our resistance ladder in our cruise control, and we're going to measure that voltage drop because our resistors in here are different than our resistors in the 2012. So what I'm going to do is I'm going to take my feed, which is white here, and I am going to attach that to my 3V3, right? Because I'm going to send a 3.3 voltage through here, and then I'll measure my ADC signals as it gets returned to me. The one catch to this is we do have to drop this down with we have to have like a pull down resistor to pull down our signal as it comes through. So bear with me here. I'm just looking for another. Okay, so I got my other alligator clip. So I'm going to clip that on here, and I'm going to connect this to pin number 34, which is one of my ADC pins. Now, the one thing though is we need, as I said before, we need to have a pull down resistor on this. So I'm going to plug it into my breadboard here. I am going to take one of my, I'm going to take my pin here. I'm going to plug it into the same breadboard section. I'm going to plug this into ADC 34. Okay, so that's number 34. So that's good. And then what I'm going to do is I am going to grab a resistor. Now, I know I need a 2.2 thousand ohm resistor. I wonder if I have my one here on my desk. That is 9,000, so that's not right. You know what? Bear with me, guys. I'll be back in just a second. I'm just going to go get one out of my drawer. Okay. Well, that took a lot longer than I anticipated. So we're going for 2.2. So we got here 2.2. Now I'll probably find it on my desk now that I see the color of it. And here it is, 2.2 ohms, 2.2 thousand. So let's just double check. .2, just like we thought. Okay, so what we do is we're going to take this and we're going to take it to the ground. Okay, so now that's in. So now what we need to do is we need to get this all programmed up and get it set so that we can actually start reading these ADC signals. And then what we'll do is we'll start outputting as if we had the 4 buttons on this chip here. So we're actually in luck. Everything is kind of set up for us to do some testing. We just might need to change some of these wires, okay? But let's go ahead and I believe I have this set up correctly. So let's move over to some coding now. So okay, let's go here with this one. So the first thing we need to do is we need to set up our ADC pin. Okay, so I am going to come over here and I'm going to say cruise control globals. Okay, and the first thing we want to do is set pins for cruise control. And what we're going to do is we're going to set our, we're going to define, this is upside down. Okay, that's better. That's better. Okay. Where were we? Over here. Define, and we're going to call this our ADC, no, we're going to say pin underscore ladder underscore ADC, and we're going to set this as pin 34, right? Because that's the ADC pin I chose. Okay, we'll go back and we'll start setting the other pins, but we'll do that later because we're not even outputting from this. We just want to honestly start reading. So what do we need to do? We need to come to our setup, and in our setup, we're going to need to set our pin. So we're going to say pin mode. I'm sorry, not pin mode. We're going to say analog set attenuation. ADC underscore 11 dB, and that allows us to kind of read that pin 34 as it starts coming in and out. All right, so now we have that. Honestly, we just want to start reading some of our settings. So I'm gonna actually close these out so it becomes a little bit easier for us to read this. Leave our setup open. We'll close this because read response, remember, is our audio control response. And then we have our loop down here. So we're going to say read cruise control. And I'm going to put it up here. And so the first thing we really just want to do is we want to read what ADC do we get when we actually set up our or kick off and send a voltage through our cruise control button. So the first thing we're going to do is analog read pin ladder ADC. Okay, and let's do serial.print ADC. Now let's get our ESP32 plugged in. Okay, so Let's load our code in. Okay, so here is our ADC. All right, you guys can see that our ADC is flowing through. And what I'm going to do over here is I'm just going to say, okay, resting ADC at 2 point, or actually, let's do this. Assuming a 2.2 thousand ohm pull down resistor, resting ADC is about, let's say, it looks like it's 630, okay? Then we're going to say on off ADC. So that's about 1980. Let's say it's 1980. Our ADC for set down, let's say that's 1335. And set plus, sorry, resume plus. We'll say it's about 980. Now, what do we do with cancel? What I'm going to do is I'm going to check my... I'm going to check the wiring diagram and see if we can do some math to like rough estimate where it should land using just simple like ratios or something. You know, let's just see if there's an easy way for there to be some sort of proportional change here. All right, so in the 2016, what we saw before, remember 8.76, we have on and off, which is 1.91. We have set minus, which is 3.65. And then we have resume, which is 5.38. So let's change the order of these. And let me see if I can find cancel in the wiring diagram. Okay, these numbers all check out, and we have cancel, which is 1400. So where would that put us? These are like inversely proportional to one another. Let's see. Okay, Chat GPT. We're going to give Chat GPT a shot. I have 4 scenarios with 2 variables which seem to be inversely proportional to one another. 630 to 8.76, 980 to 5.38, 1335 to 3.65, 1980 to 1.91, blank to 1.40. Can you find blank? Okay, so it says my blank is roughly somewhere in the ballpark of, let's say, 2,700. Again, this is ChatGPT, I don't have the actual switch on me, but we will find a way to make this work. Okay, so let me plug this back into this switch, which again, I am like super disappointed that I can't seem to find. I think I'm mostly disappointed because I bought it brand new. So with this all being said, now we have our numbers. What we want to do is we want to create a range over which we can actually, let's say, impact the behavior of the system. So we're going to come back up to the top here, and we're going to come under the cruise control section, and we're going to say, define ADC resting underscore max. Let's just call that rest max. Keep it simple. And we're going to call that. Now remember, we want to set a range, not the actual specific one. So somewhere halfway in between here. So let's say 800 is my resting max. Define ADC, let's say res underscore min. Define ADC underscore res max. And we want this to be, you know, kind of in that range there. So we're going to say the minimum when you press res should be 900. This is going to allow for like a little bit of a variance, because remember, when we press this res button, we see it kind of fluctuates a little bit. And we're going to set the max at somewhere halfway in between, let's say. You know, res and set minus. So let's say we're going to set it as 1200. Okay, we're going to set our ADC set minus, or let's say set min. And we'll set that at, let's say, 1300 seems a little high, so I'm going to say 1250. And then we're going to say ADC underscore set max equal to, and again, we're going to say somewhere in between set minus and on and off. So I'll say somewhere around 1600. Define ADC on off min. And let's just copy paste this, make it easier. Max. This will be, let's say 1900. And our max will be somewhere in between. So let's say, I don't know, 2200. And last but not least, we're going to define ADC, cancel, min, and we'll just set that as 2300. And define ADC, cancel, max as, I don't know, 2800. Okay, so now we have our ranges, right? So each one of these numbers falls within that range up here. So we can actually say something along the lines of, okay, what are we currently doing? So let's say serial dot, let's say this. We're going to create ourselves a range, and we're going to say if ADC, and you know what? I don't know if there's a between. I'm gonna check on here. Doesn't look like it. So we're gonna do some copy pasting, and we're gonna say, okay, is greater than. All right, let's say if it's less than ADC rest max. Serial.print resting. Okay. And then we're going to say else if ADC is greater than ADC res min and, not and, ADC less than ADC res min. And what do we want to do? We want to say serial.print resume plus. All right, and now we're just going to take that and we're going to copy paste it. Okay, and we're going to change this text to set minus on off cancel. Okay, so we see that we're resting. Let's press our resume plus. Okay. Unfortunately, oh, no wonder. I put greater than min, less than min. That doesn't make sense. Okay, resting, resume plus, set minus. We have our on and off, and unfortunately we don't have a cancel button, so we can't test that. But on the bright side, now we have this set up. So now what we want to do is we want to set this up so that only if and only we have our cruise control on and off will this actually execute. So let's do this. We're going to create a variable up here that we're going to call something like, let's see, Boolean, because it's on and off, cruise control bool, and we're going to set it to false because when the car turns on, it's off by default. Okay, so now we're going to say, we're going to come down here and we're going to say something like if cruise control bool equals true, so we only want to do this if our cruise control Boolean has been engaged. And when do we want to engage it? When we press on and off. So let's do cruise control. Oh, but we won't be able to execute that in here because it's only going to do it if this Boolean is true. So let's do over here something like if ADC is greater than ADC on off min and ADC is less than on off max, then we will do something like on cruise control bool equals true. But that's not going to work for us, right? Because we can't just set it to true, because what if we press it again, we want to turn it off. So what we can do is we can do the opposite. We can say flip it to the opposite. And maybe over here what we can do is we can always print whether or not it's on. Okay, so that last digit is a 0 because it's off. Now if I press on and off in the middle here, now the catch, the issue we have here is that what happens if I hold the button, right? I'm not always going to be able to just tap it. And even when you see I tap the button, like it's hit or miss how many times it registers. So we have to add something in here so that we know that it's not always, like it's sort of what they call it, I believe, is a debounce. And if we look here, my buttons work. So when it's on and when I turn it off, it's reading an ADC, but it's not actually doing anything, right? It's not printing, which means now we have a logic that works. So it only works when that's on. But we have to make sure that we're controlling this button and the sensitivity of it. So what we want to do is we want to add something called a debounce, and we want to just make sure, like, okay, was the button last pressed? So let's do that. So let's come up here. We're going to add in another Boolean that says on and off was pressed. And then we are going to add in, let's say, timing that tracks how long was the button pressed, how long ago was it pressed, and so on. So let's do that by adding these variables in here. And we're going to say 200 milliseconds is about the debounce. If we need to, we can go in and we can adjust that as necessary. But let's come back over here and let's modify this so that we're not getting as much noise. So we're going to say, okay, if the range is in there, if on off was pressed, and this is basically going to maintain whether or not we're holding the button. Okay, so now we should be able to see whether or not our cruise control is turned on and off. And down here, we have the action of what to take while the on and off button. Now, I can remove this part because it's not relevant, right? We're handling all of this on and off up here. So let's just do that, and then we'll register each of the actions for these, you know, henceforth. So I'll go ahead and reload it. Oh yeah, I'm missing one last thing here. And we all, because we want to turn off this at the end of it all, right? So this is like, okay, I press the button, now the button's being held. What do I do while the button, and then finally when I let go of the button, I turn off that it was being held. All right, so now let's see. If I press these buttons, sure, my ADC changes, but nothing happens. If I press this, okay, now I get my resting. Okay, so my buttons go up, down, and this is fine. This is how I want them to react. And then if I press the cancel button again, it turns off. Okay, now see, I'm holding it. And as soon as I let go, then it triggers. Now, if I press it and hold it, it doesn't like flicker on and off. It's just going to measure and check when it's finally complete. Okay, so now that we have that done, the next thing that we will ultimately do is we will work on getting our pins assigned for our buttons, right? Remember, we need 4 of them. So we're going to come back up here and we're going to say define pin resume, and that pin is going to be 32. Define pin set as 33. Define pin cancel as 25. And define pin on off as 26. So then honestly, it's a little straightforward here, right? At this point, we're just going to be setting these pins on and off, you know, in our different sections. So digital, right, pin on off high, digital right, pin on off low, and then down here we're going to do something very similar. We're going to say, okay, pin resume, pin set, pin cancel. Now, the only thing I want to call out here, let me just come back up, resume, set, cancel, on and off. The only thing I want to call out is that what we want to do is we want to make sure we reset these pins every time the loop runs, right? Because we don't want these to be held. So we're going to do another clear, let's say, I could probably put it in the other one, the one right there, clear outputs, but I kind of don't want to. I want to put it in a separate section. So let me do this and say void clear CC outputs, right? So that's cruise control outputs. And I'm just going to grab 3 of these because this is straightforward. Oh, actually, I must have added this in before. So, no, it's actually in there. I don't need to change it. Okay. So, That's going to reset them. And then the last thing I have to do is I have to come in here and say, okay, I have to set my pin mode for my 4 pins to pin underscore resume, pin set, pin on off, and pin cancel. Okay? So at this point, now I've written all of the code. I can do some testing of these actual things with the LED to make sure it works with this my little ULN 2003. But honestly, I've already demonstrated that it works. Really, that would be kind of a waste of time. So at this point, all of the code has been written to allow us to control our different buttons on our steering wheel. We have cruise control. Now, we don't need to do anything with the heat because the heat is managed by a module. I think I showed that to you guys a long time ago. It's managed by a module inside here. So we don't need to do anything with that button. Based on our thresholds, if you have a cancel, and honestly, if I find my other spare switch, I will demonstrate it for you guys. But ultimately, we'll manage everything accordingly, and we'll have it all wrapped up into this ULN with the resistance ladder. And then over here, we have all of these buttons work. So everything at this point should work and function with zero issue at this point. And I am a bit curious now, if I plug this in and give power to my Malexus, I should be able to actually track everything through the system here. So let's give this a shot. So we have our cruise control, so nothing happens when we press up and down here. When we press the button, now our cruise control is on. Despite cruise control being on, if I press down, we get our LED lighting, and you see that the system is actually registering down. I can press source. That's going to give me my other LEDs. If I press right here, I should get the same as favorite up. Okay, and I am. If I take out my pin here, right, which is my alt controls, pretend this is a switch. I see alt controls is turned off. So now my right and my favorite don't register the same thing. I plug that back in. Now I have my alt controls back on. So now I have alt controls giving me the same output, and my cruise control is still on. So when I press up and down, you see those work. If I press the button again here to turn cruise control off, now our cruise control is off. So now we have everything managed through the ESP32. What I like to do is take all of this crazy. Now all of these LEDs and resistors will get replaced with actual resistors and the BCM line coming in and going out. But what we're going to do is we're going to wrap this up into a nice, neat package through KiCad, and I'm going to design a PCB so that this can be plugged directly into your harness, directly into your clock spring, and you should be ready to go without doing anything internally in the steering wheel, to resistors, to anything. So, guys, this has been a little bit of a long one. I hope we're wrapping up on long videos. Most of the design has been complete, most of the reverse engineering. So at this point, it's really just going to be about building out our mini board and actually testing it out in the car. So thank you very much, guys, for joining. I hope you learned something. I'll catch you in the next one. See ya.